Weak monotonicity. The previous characterization involves both the social choice function and the payment functions. We now provide a partial characterization that only involves the social choice function. In section 9.5.5, we will see that the social choice function usually determines the payments essentially uniquely. Definition 9.28. The social choice function f satisfies weak monotonicity, WMON, if for all I or v minus I we have that f of vi v minus I equals to a not equals to b of, which is equals to f of vi prime v minus I, implies that vi of a minus vi of b is greater than or equals to vi prime of a minus vi prime of b. That is, WMON means that if the social choice changes when a single player changes his valuation, then it must be because the player increased his value of the new choice relative to his value of the old choice. Theorem 9.29. If a mechanism f P1, P2, P3 until Pn is incentive compatible, then f satisfies WMON. If all domains of preferences Vi are convex sets as subsets of an Euclidean space, then for every social choice function that satisfies WMON, there exists payment functions P1, P2, P3 until Pn such that the tuple of f P1, P2, P3 until Pn is incentive compatible. The first part of the theorem is easy and we will bring it completely. The second part is quite involved and will not be given here. It is known that WMON is not a sufficient condition for incentive compatibility in general non-convex, more precisely non-simply connected domains. Proof. First part. Assume first that f P1, P2, P3 until Pn is incentive compatible and fixed I and b minus I in an arbitrary manner. Proposition 9.27 implies the existence of fixed prices Pi for all little a and capital A that do not depend on Vi, such that whenever the outcome is A, then bidder I pays exactly Pa. Now assume f of Vi v minus I equals to A not equals to B equals to f of Vi prime v minus I. Since a player with valuation Vi does not prefer declaring Vi prime, we have that Vi of A minus Pa is greater than or equals to Vi of B minus Pb. Similarly, since a player with valuation Vi prime does not prefer declaring Vi, we have that Vi prime of A minus Pa is less than or equals to Vi prime of B minus Pb. Subtracting the second inequality from the first, we get Vi of A minus Vi of B is greater than or equals to Vi prime of A minus Vi prime of B as required. While WMON gives a pretty tight characterization of implementable social choice functions, it still leaves something to be desired as it is not intuitively clear what exactly the WMON functions are. The problem is that the WMON condition is a local condition for each player separately and for each V minus I separately. Is there a global characterization? This turns out to depend intimately on the domains of preferences Vi. For two extreme cases, there are good global characterizations. When Vi is unrestricted, i.e. Vi equals to R to the A, and when Vi is severely restricted as to be essentially single-dimensional. These two cases are treated in the next two subsections below. The intermediate range where the VIs are somewhat restricted, a range in which most computationally interesting problems lie, is still wide open. More on this appear in Chapter 12.